Hello, this is Physics 103. This is nuclear physics, and this lesson will tackle nuclear fusion. So in the last lesson, we have learned about the process of nuclear fusion, wherein you split an unstable atom, say uranium-236, and in the process, you increase the binding energy and you release kinetic energy in the you release kinetic energy from the mass used in the increase in binding energy. So in fusion, the opposite happens. So you have two small nuclei, say you have two hydrogen, and you fuse them together, and upon the process you also increase the binding energy in the nucleus, and similar to fusion, the amount of increase in this binding energy will be converted to the kinetic energy of the process. So thereby releasing very huge amounts of energy. So in nuclear fission, we see that this amount of energy is only released during the process. In nuclear fusion, in our graph, here we have a very tremendous amount of leap from, say, helium to, say, strontium. So nuclear fusion, in terms of energy release, is greater than nuclear fission. So let's examine here an example of a nuclear fusion reaction. So starting with two protons or a hydrogen nuclei, so you fuse them together forming deuterium, so hydrogen with one neutron, and then together with the product you have a positron and an electron neutrino. So this deuterium will then be used to fuse with another proton, forming this isotope of helium. So this is helium with two protons and one neutron, and in the process you also release a gamma radiation. So continuing the process, this isotope of helium combines with another isotope of helium. So if we repeat this process twice, so we will produce 2 times the isotope of helium, and then combining them both in this third reaction, we will produce an alpha particle plus 2 protons. So this type of reaction is called a proton-proton chain reaction, and its net effect is to produce 4 protons. Its net effect is from 4 protons you produce 1 alpha particle, 2 positrons, 2 electron neutrinos, and 2 gamma rays. So this process is the nuclear reaction that is happening inside the cores of stars. So inside our sun, you have a bunch of protons, and these protons undergo this proton-proton chain to produce these products. So energy is being released from this nuclear fusion, and we can calculate it. So the mass of 4 protons initially is 4.029106 atomic mass units, and the mass of the product, the helium product, or the alpha particle, the mass of the alpha particle is only 4.002603 atomic mass units. So subtracting these two masses, you would have 0.026503 atomic mass units. So this amount of mass is converted into energy in the process, and together with the release of positrons, not positrons, neutrinos, and gamma rays, there is an additional. So if you multiply this by c squared, you would get energy. And if you add in the effect of the gamma rays, you would get another 26.73 mega electron volts. So overall, this amount of energy results from the proton-proton chain reaction which happens inside the cores of stars.